Hi guys, Mr. Bennett here. So we're looking today at optimization problem solving method. So I want you to keep this in mind as we do these questions, and I will do several of these questions over a couple of videos. The key steps that we're going through are the following. Okay, keep these in mind. So the first thing is you need to have a diagram, and it needs to be clearly labelled information that you need. Sometimes you'll need actually more than one diagram. Right, step 2 will be to construct an equation that needs to be optimized. Now generally what happens with these is that you'll have two equations. One equation you'll get given that will have some information so you can get one variable in terms of another variable. But bottom line is that you will get a equation that you need to optimize. Step 3 would be to find the derivative, okay, because that will actually allows us to find the max or the min. And then the next thing would be to test whether that is in fact a max or a min by either doing your sign diagram test, or you can do your second derivative test as well. Alright, so I'll show you that later. So let's just get into a question. So this is question number 2. A radioactive waste box is used to dispose, obviously radioactive waste, in a fully enclosed lead box. Now lead's quite expensive, so you want to minimise the amount of lead that you use. We know the volume of this particular box is in fact 200 cubic centimetres. The base of the box is a ratio of 2:1, and they've sort of labelled it over here for us, so that should make life a little bit easier. Okay, so if we start looking at that, so what's the inner length of the box? Well, we know that's h, that's x, this has got to be 2x, doesn't it? Right, in terms of what we know there. Right, so now it says explain why that's happening, that particular relationship happens in part B. So if you think about it, the volume is equal to 200 cubic centimetres. Now the volume is equal to the area of the base, which is going to be 2x times by x times by the height. So we've got our answer there. So we do have our answer. What we're looking at is getting our sort of showing that. So we know 200 here is equal to 2x squared times h. So therefore, if we can cancel that out there, h is equal to 200 over x squared, so over 2x squared. So therefore that's equal to 100 over x squared. So we're going to need that information, right? That actually I haven't shown what I was trying to show there, but I've got the relationship. So here I could just cross the 2 off there. So therefore 100 equals x squared h. And that's what I was trying to show with that bit there. But I've gone a step further. I haven't really read the question. That's what I need to do though. I need to get h in terms of x. Explain why the inner surface area of the box is given here. Now the idea of doing this, so if you couldn't find that, then you could actually use that information to then do the rest of the question. Alright, so they'll give you the answer as we go through. Alright, so if we're looking at the part C, right, the surface area, which they have called area versus x, is going to be basically all the surfaces added together. So there are two lots of each of them. So that's two lots of 2x times x, plus it will be two lots of 2x times h, plus two lots of x times h. Okay, and so therefore we know what h is. We know h is equal to 100 over x squared, so that's going to be two lots of 2x squared plus 2x all over 100 over x squared plus x all over 100 over x squared. Now the key thing is you could probably do this a quicker way than I'm doing, but it's about showing the steps because they have given you the answer, so they want to see the steps. So let's expand that out and collect like terms. So that will be 4x squared when I times that by 2. That x is going to cancel out with that. So that's 2 times 2 is 400. Alright, so it's going to be 400 all over x. that x is going to cancel out with that there. So that's then going to be 2 times 100 plus 200 over x. And then finally I'm going to get to an answer which is 4x squared plus 600 over x. Now is that what I was trying to show? Yes, it is. Okay, so I now got to my answer, but I have to show all the steps. So when we do part D, what we're looking at is we have to use technology to sketch that. So I go to my calculator, right, and so therefore I'll put that into my calculator, so I'll just clear that. So it's going to be 4x squared plus 600 divided by x. Okay, and I'm going to graph it. No, I haven't got really something I'm looking for. What am I expecting to see here? Well, I am expecting to see that I can't have a negative x, can I? Because it's got to be, it's a real thing. And I'm looking for a minimum. So what I might do here is change my window. I might go from, say, -1 so I can see my axes. And let's say we'll go to, say, 30. That'll be probably big enough. You can trial and error with this. Let's go to -1 again here. And let's maybe go up to 100. Okay, we'll graph that. And hopefully we'll see a function. Now obviously that's not in my region, so if I don't see it with 100, then I will go maybe 1,000 and graph that. Beautiful. Okay, so now I know what I'm looking for, I know what I'm expecting, I can play around with that. I need to then look at my my calc over here. I'm going to do the min there, number 3. Okay, so if I go, say, 1, that will be on my left hand bound. Let's say 20, that should be on my right hand bound, and then that will give me my min value. So when x is equal to 4.21, let me just take a screenshot of that and I'll bring it across. Copy. Okay, so let's come to my optimization. So for this here, so we're going to paste that in there. And just move that, bring that down here so we can see it. Oh, actually that's gone above where I'm going. So I'll just move it up to where we're working. Alright, so part D. Right, so that's my value. So what does the question ask us to do? The question asks us to use technology to help do a sketch. Well, I've done that. So you obviously don't need to you can just do that. Find the minimal surface area of the box and the corresponding x values. So you have to actually interpret what that says. Alright, so for that particular question, you have to write down what the surface area is. So you say min surface area min is equal to 213.441 centimeters squared when x is equal to 4.22 centimeters. Okay, go 3 sig figures if you're not sure with that. Now, the next bit it asks you to do is, it says something like draw a sketch of the optimal box shape and dimension shown. Right, so that means that I have to do a sketch of the box, and I mean I've got one sort of already labelled up the top anyway. So do my box. What I do need to know is all these dimensions. Okay, so I know this side here over here is 4.22 centimeters. I know this over here is going to be 8.44 centimeters, and then the height is equal to 100 divided by 4.22 squared, and you work that out and you write that down. Alright, so that's that question done. The question sort of takes you through every part that you need to do, alright, which is really good for it to do that. Now, another style of question that you might get asked to do is like number 12, the pipelines to be placed to connect points A and B to the river. Alright, so we're going to put some pipelines, so we need to know where at X we're going to put the pump house. Alright, so how far should M point X be from M? Okay, in order to make the pipeline as short as possible. So we're going to use some information here. Quite clearly you can see a right angle triangle for that. So if I've got a right angle triangle here, then what I'm going to do, well, I'll have to call something x. So I'm going to call this distance here x. That makes that distance there x, 5 take x. Okay, and then this side over here, which is the length of the pipeline using Pythag, would be x squared plus 4. And this one over here would be the square root of 5 take x squared plus 1. Okay, so going there. So if I'm trying to find the distance for obviously my pipeline, the length of my pipeline is going to be equal to simply those two things added together. So it would be x squared plus 4 plus 5 take x squared plus 1. Alright, now remember what we're trying to do. We're trying to find the minimal shortest pipeline. So then I'd have to actually differentiate that. So that's L dashed of x. Okay, it's only in terms of one variable. So that's going to be a half of x squared plus 4 to the negative half. And then I'd times that by 2x. And then I'd have to do the same thing over here. So that will be a half of 5 take x squared plus 1 to the negative half. And then what I need to do is I would need to differentiate that. So that's going to be 2 lots of 5 take x times by negative 1. Okay, so you get the idea of what I've done there. So I've done my differentiation for that particular function. Now, if you solve that for when that's actually equal to 0, it looks like it's going to be quite messy, isn't it? Alright, so what are you entitled to do? You're entitled to go and do that graph of that. So if we change our function, so we'll just clear that. So that's the square root of x squared plus 4, and then I'm going to add on to that, I'm going to do the square root of bracket 5 take x bracket square that, and then I'm going to add 1, and I'm going to graph that. So I'm sort of looking for something in there. Now obviously my scaling is right out there, so I need to come back in with my scaling. So let's maybe make that say like 10. Okay, and we'll just graph that. You quite clearly see that I'm coming to a min there. Now I can get really fancy with it, but all I'm really interested is the value. So if I go to my min number 3, okay, let's type in, let's go left hand bound. So you can scroll across using your arrow. Right, so you go into the left hand side of that, enter, go to the right hand side of that, enter. Then I've got over here, I've got my answer, which is when x is equal to 3.33, then the length of the whole thing is going to be 5.83. Okay, so over here, now I've got this thing here, which is going to be a graph, and I know that's there going to be 3.33 and 5.81. So therefore you could say therefore minimum surface area, the minimum length when the pumping station is 3 1/3, that's what that is, kilometres from, now what's the point? From point M. Okay, so you get the idea there. Okay, now I didn't quite do that one, all of that properly, so let's do one more example in this video, and we'll do question 5. Oh, you can see all where my little things have rocked up here. Now, if we start looking at this question here, we've got a circle. Now a circle has, you could put a rectangle in a circle, alright, so they've even labelled this thing here ON as X, and it says find the area of ABC in terms of X only. So I think what I need to do there is I need to probably draw a triangle in there to help me out. So if I did a triangle for this bit here, this is in fact the triangle ONC. Alright, that's triangle ONC. We know the diameter of the triangle is 10 centimetres, so this means that that's 5 centimetres. This would be X, and so therefore this thing over here would be the square root of 25 take X squared, wouldn't it? So therefore we could say that the length of CB is in fact two lots of that, two lots of 25 take X squared, and then the length of AB, that's equal to simply 2X. So therefore the area of the triangle in terms of X only has to be equal to 2 lots of X times by 2 lots of 25 take X squared. Now you can simplify that slightly and make that equal to 4X 25 take X squared. Now it hasn't told me how I have to do everything, has it? So it's just said part A, find that relationship. Now this is a strange sort of question in terms of quite often we would give you the answer just because if you can't get part A then you can't do part B. So find the dimensions of A, B, C, D when the area is a maximum. So it's told me what I'm looking for. I need to graph that, don't I? Alright, so if I just put this into my calculator, so again we'll go to that, clear that, 4x times by the square root of 25 take X squared. You should have, keep in mind what sort of answer you're expecting when you're doing this. Okay, looking for a maximum, you can see it's quite clearly going up there, and I'm not high enough there, so maybe I need to go to, I say, 100 and graph that. Okay, you see I've clearly got my graph there. Now if I want to make it a bit more easy to see, I could probably make that, say, 8, and then maybe make this something like 50. Graph that. You can see quite clearly I've got to my maximum point there. I need to find that point, of course. So question 4, number 4 there. So go to the left hand side, enter, go to the right hand side of that next point and enter. So I've got a maximum of 50 when x is equal to 3.54. Okay, so in terms of this thing here, wrong function. Okay, so if we do a sketch of that on our calculator, right, so it's going to go up here. That's actually 3.54 and 50. So what's it asking me to do? What did it ask me to do? Find the dimensions of that where the area is a maximum. Right, so therefore, now I could also prove it's a maximum. Okay, so I can prove it's a maximum by doing a graph of area of x, doing my sign diagram. 3.54. Now I know it's a maximum, don't I? So if I was doing it, I'd go plus minus, and then that proves it's a maximum. So therefore, it's a max at x equals 3.54. Now, if I know what my x value is, don't I? Right, I know then what my my other values are over there. Now, the dimensions of my triangle, of my rectangle, I should say, it's 2 lots of this for CB and it's 2 lots of that for AB. So I haven't quite answered my question because I've got to put that in the context. Okay, so this here, right, so that's going to be 2 lots of two lots of 25 take 3.5, yeah, 3.54 squared, and that's going to be two lots of 3.54. So that's going to be 7.08. Now, just assume that's centimetres. If I do that other bit in my calculator, let's quit out of there. So 25 take 3.54 squared. Can't type in my calculator very well. 54. Okay, and do that. I get 3.53. So it's pretty well the best shape there for maximum area is what we do in most cases. It's pretty well a square. 3.54 centimetres. So therefore, going through that process. So the key things are draw your diagram, get your equation you need to maximise and minimise, and then quite often you can do that on your calculator. Good luck with those.